Good morning, students. In the last class, we are solving the problem based on fin. So I've asked you to calculate this one. What is the value of this one? Did you calculate? If you did not calculate, you calculate it now. Substitute the values appropriately. The third problem, and then you get what is this t. This is unknown here. Calculate it. Everything else is known. It is given in the question. So tell me what is the value of this one. That is t at x is equal to 80 mm. Yes, please tell me this value. Did you calculate? If we complete that, we will move to the next problem. Right. Right. Here I am writing what I have with me. Please cross check with your answer. What I have with me is 143.1 degrees centigrade. Okay, you may cross check this value approximately. And we'll move to the next problem. This is again based on the problem that we have solved in the last class. Okay, in the same problem, he is asking you to calculate the heat flow, heat convected in two cases. He is asking. So what he's asking is problem. What shall we say? Third is over. Fourth. This is fourth problem. That is 2D. We're solving. And in this, he's asking you to find out what is Q. He's saying that it is Q total, what it is. And he's asking Q up to 159 mm. That is the overall length. 159 is actually the total length. And then Q up to 80 mm. These are the things he's asking you to find out. So how do you find out the Q? Okay. If you have the what do you call the T minus T infinity my TB minus T infinity. Okay, you have used the first formula, this one, and this one. But now what he's asking you is, he's asking you to calculate Q. Okay, so he's asking you to calculate Q. In the first case, this is the formula. Okay, that is TB minus T infinity into root over HPKA. So I hope you can see it. This is the formula. Actually, we have derived it also. So TB minus T infinity into root over HPKA is our formula. I'm writing that formula here because Q we are calculating in case of a long fin here. In case of a long fin, you need Q here. This Q is root over HPKA into the TB minus T infinity. The TB, T infinity, H value, P, K, all of them are available to you in the problem that we have already solved. If we go up, we can find them. Okay, this is K, this is H, this is T infinity, this is TB, And EM you have found out. EM is 11.88. You have. So what else is required? Everything else is known. Just simply substitute them. Okay. This is equal to the H value is tell me what is the H value?
22, sir.
22. H value is 22. What is P? It is 4 times, since it is a square cross section 1. I have to take 4 into the 12 mm. Okay, 12 means 12 into 10 to the power of minus 3 we have to take, because we have to take it in meters. And the K value 51, 51.9. That's what is given in question. And the area is asking. What is the area here? It is this one.
Sir, is Q 15?
Telling Q. Yeah. Q
I thought
value, what I
somewhere
have it
around.
is
Yeah, sir, 14.65.
14.66 watts. So the area value is 12 into 10 to the power of minus 3 whole square into under root is there only for this one. And TB is 200 and T infinity is 35. So Q is equal to 14.66 watts. So this is what we have for the first one. He's asking in this problem. And in this problem, he's also asking you to find what is the Q up to 159 mm. He's asking. Okay, Q up to 159 mm. How do you find that? See, if you have a fin here like this is wall, and on this wall, what you have here is a square fin. Actually, this is square fin. Whether you consider square fin or any other thing, the matter is same anyways. So it's like this. Now the whole length is actually 159 mm. Okay. So out of this whole length, you got this. Okay, it is 14.66. What he's asking you to find is, he's asking you to find heat convected. Okay, here you can see he's asking you that he's asking you to find out the heat convected. So what is this 14.66? It is convected and conducted also. So out of this Q is actually Q conducted plus Q convected. So what you can do is, if you want convection, Q convection is equal to Q minus Q conduction. You can take. Okay. So how do you take that? Okay. How do you get this Q this Q you actually have it. It is 14.6. How to get this Q conducted? That's the question here. Okay. To get that, you actually have the temperature on this tip. Okay, temperature on the tip. Using this, you can find out what you can say is Q is equal to root over HPKA into this temperature you have to use now. Okay, temperature of the tip minus T infinity. Okay, so this will represent the remaining heat, the heat that is left out. Okay, so what I'll do is I'll put this value here. So tell me, what is the T tip? The previous problem we have solved it actually. At temperature, at pin tip. Did we solve it? We did not solve. No, we did not solve. We have to solve for it. Okay. How do we solve for it? Using this one itself. And it's gonna T minus T infinity by Tb minus T infinity is equal to e power minus mx. We will use, so T at x is equal to 159 mm, right? 159 mm minus the T infinity is 35 and Tb is 200 minus 35 again. E power minus m is 11.88 into 80 into 10 to the power of minus 3. Tell me, what is T at x is equal to 159 mm? What is this value? Please calculate and tell me. Yes, what is this value? Somebody please calculate and tell me.
99.1.
99.1. It cannot be 99. It is somewhere close to 35, I believe.
Sir, 59, I guess.
9.92.
Huh?
59.
50, 60, sir.
59.9. 60.
59.92, sir.
59.92.
Yeah.
99.1.
I'm sorry, wait. See here, in place of x, we actually put this 157, 159. Now you tell me. It's not 8.
59.92, sir.
What is the value of temperature? Now you tell me.
Yes, sir. It's 59.92.
Even after that, it is 59.
Yes, sir.
I don't think so, because it will be close to 35 degrees centigrade. You are calculating it at the other length, right? Isn't it? Okay, it need not be 35. There might be some other reasons which I will discuss. Okay, 59. Let us take
92, sir.
59.92 degrees centigrade. Okay, which may be true. Let me check that. Okay, now if I have to calculate this one, this is equal to root over the HPKA. The H value is given as 22. The P is 4 into 12 mm, 12 into 10 to the power of minus 3. The K value is 51.9. And the A value is 12 into 10 to the power of minus 3 whole square into this T tip is 59 point. What we got just now?
92, sir.
92. So tell me, what is this?
Two point two one.
2.1. All right. So this is what. So now I'll take this and substitute it here. 2.21. Now I'll get what is Q convected till 159 mm. So that is equal to 14 minus 2 is something like
4.
12.44 watts. So that is Q convection up to 159 mm. The same way you have to calculate it for 180 mm. Okay. So for that, what you have to do is, again you take Q is equal to Q up to 80 mm, or this is Q convection is equal to Q minus Q conduction. So Q conduction in this case has to be Q is equal to root over HPKA into TB minus T infinity. That is equal to this TB has to be the temperature at 80 mm. Okay. So you substitute remaining things. The H value is 22. The P value is 4 into 12 into 10 to the power minus 3 into K is 51.9 into A is 12 into 10 to the power minus 3 whole square. Our HPK by now we must have got it. The T80 mm you have found out in the previous problem. Where is that? This is the one. Okay. 98.75. It is
5.66.
98.75 minus the T infinity is 35. So you get Q conduction. What is this value?
5.66.
5.66 watts. So now you take this value and substitute it here. This Q value already have as 14.66 minus this one is 5.66. This will give you 14 minus 5 is 9 watts. Okay, Q up to 80 mm. So he's asking you to find this one, and he's asking you to find this one, and he's asking you to find this one in the first question. So you're done with that. Okay. Next question, what he's asking is this one. Okay, let me put this question once again here. Look at the question here. Using the same problem again. Okay. What you have to do is, now the case has turned out to be heat dissipated by the fin at 159 mm length with end insulated condition. If it is end insulated condition, here in this data book, you have a second case here. In this second case, the formula, whatever the formula that you have previously, this part is a first case formula. This is multiplied with tan hyperbolic ml. Okay. So you have to multiply the previous one with the tan hyperbolic ml. Then you will get the short fin, Q value. Short fin with end insulated conditions. Okay. So what he's asking is, first thing he's asking you to find out Q, what is this? And then also find the heat dissipated up to 0.08 meters. Q up to 80 mm again he's asking. Okay. So these two he's asking in this problem. You have to solve for it. For solving it, you need Q. The Q value is taken as, Q formula is taken as root over HPKA into TB minus T infinity into tan hyperbolic into ml. Okay. You have all the things. Now just substitute and you will get it. H value is 22, the P value is 4 into 12 mm, 51.9 is K, and the A is 12 into 10 to the power of minus 3 whole square. The TB value is 200. TB value is 200. T infinity is 35. Tan hyperbolic of M value is 11.88 into L. What is the L in this case? L is 159, 0.159. Now you tell me what is the Q.
14.004.
14
14.
point.
14, sir.
Let me check. Yeah, it is 14 watts. The Q value is 14 watts. Good. So we'll move to the next part of the question. It is Q convected up to 80 mm. You have to find out. So how do you do that? For finding that, you will have to actually take Q up to 80 mm will be equal to Q minus root of HPKA into the temperature at 80 mm minus T infinity. This is the thing that we have discussed in the previous problem. Based on that, I have written it directly here. Okay. We have Q with Q here. Q is 14 minus root over H value is 22. P value is 4 into 12 mm. The K value is 51.9 and the A value is 12 mm square. Now, what is the T 80 mm is the question here.
98.15.
T 80 mm you have to take appropriately here. Let me move to the problem.
Is it
Where is that?
98.75, sir?
106.
Just let me see. This is the thing, 106.85. Okay. At 80 mm in the second question, the second problem, at 80 mm, it is 106.85. So here, what you get is this into 106.85. I guess it is 35 into tan HML also you have to write. Tan hyperbolic ML, because this is the second case, tan hyperbolic ML obviously will be there. So into tan hyperbolic, the M value is 11.88 and the L value here in this case is 80 mm. No, L value is the whole thing you have to take, whereas 159 itself. Wait. This is ML, it should be 80 mm. 8 into 10 power of minus
9.275.
9.275 is Q up to 80 mm. 9.27 watts. This one is asking you to find and this one is asking you to find. That is this problem. Now we'll move to this problem. First two things we can take out. This is problem 2C, meaning this is short cell, not insulated case. Not insulated. Determine the heat flow through the fin, he is asking. So how to find out? For finding it out, you have to use this formula now. Okay, this will be this formula. Okay, this big formula, you have to reproduce it there. This one, I'm writing it. Root over HPKA, that is on the other side. I'm taking on this side. This is just multiplication. So I'm doing it this way into tan hyperbolic ml tan hyperbolic ml plus HL by mk by 1 plus tan hyperbolic. Okay, let me write it as this HL by mk into tan h tan hyperbolic of ml. Okay, so that's how your formula will turn out to be. So in this, we have something called as HL. Okay, what is HL? You must understand. HL means convection at the tip. That is heat transfer coefficient right at the tip. Okay, if the heat transfer coefficient is given to you right at the tip as a different value, you have to take it as a different value. Otherwise, you have to take the value that is given for the normal atmosphere present. So it is 22 watt per meter square Kelvin itself in this case. Okay, so keep that in mind. Now, the TB value is 200. The T infinity value is 35, and root over the HP, the H is 22, P is 4 times 12 mm, and then the K value is 51.9 into 12 into 10 to the power of minus 3 whole square, that is your A, into the tan hyperbolic of the M value is 11.88 into the L value you have to write now. The L value in this case is 80 mm itself. Okay, there is no further length in this case. It is just having a length of 80 mm. So you can substitute that 80 mm here. That is tan HML plus HL by MK. The HL is 22. Just now I told you why it is 22. And the M value is 11.88. And the K value is 51.9 by 1 plus the HL value is 22 by 11.88 into 51.9 into tan hyperbolic of ml. 11.88 into 80 into 10 to the power minus 3. So this is your Q expression. Calculate and tell me what is the value of Q.
11.0.
11.06 okay watts.
3.
03, yeah? Doesn't matter much. 0, okay, 11.03 watts. So this is what he's asking you in this question. Okay. Now we have essentially solved the same problem in 6 different ways. Okay. For first 3 cases, you have solved for temperatures. Next 3 cases, you have solved for Q. And next, again, you can solve for efficiency also in all the 3 cases. Okay, I have not done that. You can do it for yourself. Okay. So what I want to do is, I just want to tabulate the value that we have done so far. Okay. What we will do is, let me put these values in the form of a table. Okay, we have 3 cases here. In 3 cases, you have found out the T value and Q value. Let me write the first case here, long fin case, and then we have tip insulated case, short fin with tip insulated case, and the third case is tip not insulated case. These are the 3 cases we are having. And first you have found out the temperatures, then you have found out Q. Okay. So let us tabulate all those values here. In the first case, you have found out the temperatures in 3 different things. Okay, tell me what are these temperatures. See, first of all, what I have found out is the temperature at 80 mm and the temperature at 159 mm. So essentially we got 2 temperatures here. The third one, temperature at 80 mm. What is it? Temperature at 159 mm. What is this? Tell me. And here also you have found out the temperature at 80 mm. And here also you have found out the temperature at 80. Tell me all these values that you have already have with you. In case of long fin, what is this value? T 80 mm. This 98 point something. 98.7. And T 159, 59.6 or something. All are in degree centigrade. T in this case, what is it? T in this case is 106.84 degrees, and T at 159 mm is 83.72 degrees centigrade. And here in this case, the temperature value is 143 degrees centigrade. Next, we'll move on to Q also. The Q overall is Q total. Q total in the first case, what is this? This 14.66. That's, see the time is up. Now we will conclude it today. Conclude it here in the afternoon class, that is at 12 o'clock. I'll be dealing it. Keep that in mind.